what's up? Not really sure what that was all about, but I do want to welcome you back to Science eLearning, episode 6. The plan today, we're going to go over some of the answers that were due yesterday and then talk about a quick lab/activity that you are going to complete either Wednesday or Thursday, due Thursday at 4. Let's go. And away we go. These are the answers to the assignment that was due yesterday at 4 o'clock. Thanks to those of you who submitted on time, which was most everyone. If you didn't, you can always turn in late for partial credit, even after watching this video that presents all the answers in your face. Questions 1 and 2. 1 asks how many moons approximately are in the solar system, and 2, true or false, the Earth's moon is the largest in the solar system. That was answered in a video. We can take a look at this picture. We can clearly see that Earth's moon is not the largest in our solar system, and not pictured here are a lot of other moons that we know of in the solar system. There are approximately 150 to 180 moons in the solar system, and so the question 2 is also false. There were 4 moons that are larger than Earth's moon. Question 3, the moon blanks around its own axis. And question 4, the moon blanks around the Earth. Let's look at this picture and remember that rotation, from before spring break we studied this, rotation is when an object spins around its own axis, whereas revolution is one object orbiting another object. So back to the answers, the moon indeed rotates around its own axis and revolves around Earth. Question 5, this is from the second video, and the moon's gravity pulls on Earth's water, creating high and low tide. That is absolutely true. We can quickly Google it and find a picture, a cartoonified picture, but that tidal bulge, remember Earth is rotating, which is why we have multiple tides, high tides a day, thanks to the moon. Also thanks to the moon, Earth's axis is stable, so we have predictable climates and seasons in parts of the Earth, but more importantly, predictable climates. Without the moon's gravity stabilizing Earth's axis, this axis may significantly fluctuate throughout the Earth's orbit around the sun or over centuries, and really would change climates to the extent that life as we know it, or life as we knew it before the pandemic, would not be the same that it is. So that is indeed true. That one is also true. Question 7, how much bigger is the Earth and the moon? And question 8, compares the gravity between Earth and moon. If we look at this picture, we can see by diameter that the moon is 3/11 the size of Earth. So Earth is about 4 times as big as the moon. And then this cartoon, not drawn to scale, shows that this astronaut, his mass does not change from Earth to moon because mass is not impacted by gravity. However, weight is. He is 1,200 newtons on Earth and 200 newtons on the moon, meaning that gravity is 1/6 as strong on the moon as it is on Earth. Questions 9 and 10, how long is one moon day and one moon year? So how long does it take for one moon rotation and one moon revolution? You could quickly Google this and you'll discover that it's the same answer. Or you can check out this May Moons 2005 poor resolution picture from Wikipedia and count how many days are there between the new moon phase and the next new moon phase. And you would know that it is approximately 27.3 days for both one rotation and one revolution. This has significant impact and implications in terms of the moon's orientation to Earth. I drew this picture. It's not drawn to scale, but it's showing us that the moon is indeed phase locked with Earth. This is kind of a top view. That's maybe the North Pole. But you can see that if we were to plant this orange reddish flag in this side of the moon, that as the moon revolves around Earth, the same side is always facing Earth, and that's because it's revolving and rotating at the same rate. This is a more accurate picture from space, and obviously only half of the Earth is illuminated at any one time. Same thing for any half of the moon. They're not 4 moons. This represents the moon revolving around Earth. But half is illuminated and half is dark because if we pull back even further, and again, not to scale in any way, the sun is shining on only half of the moon and half of the Earth at all times. And we'll talk further about that next week. Near the end of the assignment, you did have to find a picture of the near side of the moon. That's the side that is always facing Earth. Again, sometimes it's illuminated, sometimes it's not. And a picture of the far side, the side that we've never seen from Earth. This obviously was taken from space. A side-by-side comparison, there's clear differences Obviously, the far side of the moon, you can see, has many more craters. There have been a lot more space rocks that have impacted it, partially because the near side of the moon is protected by Earth from many flying space rocks, and the far side of the moon does protect Earth from a lot of, again, rocks flying through space. Question 13 involved a little bit of math. You were given the distance, the average distance, moon to Earth. And if we were traveling 1,000 miles an hour, how many days would that take? Well, if we're traveling 1,000 miles an hour, it would take us 239 hours to travel 239,000 miles. And 239 hours is approximately 9.96 days, if you could travel 1,000 miles per hour. All right. That wraps up the assignment. No need to correct your answers and resubmit, but definitely check to make sure that that all makes sense and that your answers are close to accurate. And there's Chip O. He is indeed moonstruck. Let's get to the lab.
For this lab, you need two things. You need a sphere that is half light, half dark, and you also need something to serve as a light source. It could actually be a light source, it could be a wall, it could be a set of windows, or it could be a self-portrait that you painted of yourself years ago. So what we're gonna do, we're gonna hold the sphere in 8 different positions and simply draw what we see. Let's take a look at position 1. Position 1, we're simply holding the sphere so the illuminated half is facing the light source. And we're gonna shade in the circle for number 1 for the shaded part that we see on our lab sheet. We're gonna rotate 45 degrees. Key here, we wanna keep the light half of the ball always facing the light source. So after a 45-degree turn, you're gonna draw what you see in your lab sheet. And then we're gonna move to position 3. I don't know what Fox is singing about, but we're gonna draw that.
That's 3 out of 8 positions down, also illustrated. So hopefully you can finish the other 5. Please remember to download the lab sheet from Canvas. We've already completed 1, 2, and 3 on side 1, so it's up to you to finish 4, 5, 6, 7, and 8, and then move to side 2. Side 2 presents the 8 major moon phases and their names and pictures. So what you have to do is match the pictures on page 1 with the actual names on page 2, and just write the names underneath the pictures on page 1. Spoiler, the first position is new moon. Hopefully that made some sense. If it's terribly confusing, please feel free to email me or just wait until our Zoom class tomorrow. We're going to talk about not just the results, but also how to complete this lab then. That's all I've got for you today. A big thanks once again to Diet Dr. Pepper and Mini Marshmallows for sponsoring this episode.